Hey, Beakemsters, this is Mrs. Valoy bringing you the last edition of Blankwalle, Chapter 15. This is Section 10. Hopefully it'll be a one-part series, so I'll be done with this pretty quick. So it's the effective structure on acid-base properties, all right? And how does structure, fit this in? Well, structure determine function, right? Really, which structure of the ones we're going to be looking at will provide the weakest bond with the H, okay? If it has the weakest bond, it's more likely to fall off. All right, and if it's going to be more likely to fall off, it's going to be more acidic. Okay, it's going to create more H pluses, if you will. So if you have a binary acid, the factors that determine on the acid characteristics, it's bond polarity and electronegativity. All right, so if you look at these different examples, all right, here is your partial positive, here's your partial negative. The more polar it is, the more electronegative the other element is, the weaker and weaker this bond is, and it becomes more and more ionic-like, all right? And ionic is a total give and take, if you will. So the H will more likely to fall off the more electronegative the anion is, okay? So if you look over here, this is not acidic at all because hydrogen actually has a higher electronegativity, than lithium does. And so it's going to be pulled this way. It's an ionic, if anything. There's not an acid. Over here, H and C have the same electronegativity, so it's not going to come off, all right? That's equal sharing. The bond strength is pretty high. But over here, notice that fluorine is a big 4, isn't it? And so that's more electronegative. It's more likely to come off, okay? But wait a minute, didn't we say earlier that fluorine or HF, hydrofluoric acid, is a strong weak acid? But we said HCl, HBr, and HI are actually more acidic. All right, well, what's up with that? Fluorine has the highest electronegativity, so shouldn't it be a very strong acid? The answer is not quite. Notice that this example, these three here, they're all in the same period. All right, so yes, HF within period 2 is the strongest acid, but it's not a strong acid. All right, so what gives up with the periods then? Okay, well, let's check this out. This chart's pretty handy. It says if I go left to right, it's become more electronegative. Okay, so that's what we just said here. Okay, so those are the examples above. And so the HF, yes, is the strongest acid of period 2. But what about going down? All right, so the strength of bonds, the strong bonds are reluctant to break even in solution. So the smaller the size of the anion, the stronger the bond. Why? Because you have a greater attraction between electrons and the protons in the other nucleus. So that's going to increase your strength. So if you look at the HF, HCl, HBr, notice that we're going down the period. Notice that the bond energy goes down as well, all right? So it's a weak acid. It's a strong weak acid, but still a weak acid. All right, but notice that these are strong, and HBr is even stronger than HCl. Why? Because this bond energy to break the H off the Br is less energy to break than HCl. So the smaller the size of the anion, the stronger the bond. So the larger the size of the anion, the weaker the bond and the more acidic it's going to be. All right, so let's look at problem number 50. Let me scroll down here. Looking at a periodic table, all right, or maybe just even use, let me scroll up here, this chart up here. What's the relationship between the S and the SE? All right, are they in the same period or in the same group? All right, well, hopefully you figured out, here they are, they're in the same group. All right, so which one is going to be more acidic? The larger anion. So that would be the H2SE, all right? So the hydroselenic acid, all right? What about HBr or H2SE? So now I'm going across the period. Well, HBr, the bromide, is more electronegative than the selenide. So the HBr is going to be more acidic, okay? So those are your binary acids, but a large number of our acids are not binary. They're oxyacids, all right? So let's scroll down and see what this is all about. All right, so here we have an oxygen between, the non-metal and the hydrogen, or maybe even the metals in like the case of chromate and dichromate. So what's going on here? If Y has a high electronegativity, all right, so this other element besides oxygen, then the hydrogen tends to be acidic. So if I look at I, Br, and Cl, which is the most electronegative of those three? It's the Cl. All right. Well, look at the Ka. It's the lowest, or I guess the highest number, the least negative exponent. So this is your strongest of the three acids. Okay. And so here we're looking at the 3D model of this HOCl business. So the Cl has a high electronegativity. We know oxygen has a high electronegativity. So in a sense, the electrons are being pulled further and further away from the hydrogen, weakening the bond, making it a stronger acid. So if this is an addition to the oxygen electronegative, right, it's going to further pull those electrons away from the hydrogen. Okay, let's go to the next page. All right, so what if X has a low electronegativity? All right, the compound tends to be basic. That's why, let's say, sodium hydroxide is basic because sodium has a very low electronegativity. So in the case of sodium hydroxide, the H doesn't come off, the OH comes off. All right, so that might make some sense there too. So also, if you look at the structure, the more oxygens around that nonmetal, the more acidic the compound is. And that is why your perchlorate is one of the 6 strong. Because not only do we have one oxygen and chlorine pulling on those electrons, but their other 3 oxygens are there too, pulling on those electrons, weakening this bond. So here I have 3 oxygens, here I have 2 oxygens, here I have 1 oxygen, and notice what's happening to our Ka. It's going down. So the fewer oxygens, the weaker the bond, or assuming the stronger the bond, because it's not being pulled as much. So the stronger the bond, the weaker the acid. Okay. So again, it's all about this electronegativity. So if I have a whole bunch of electronegative things pulling on those electrons away from hydrogen, it's going to weaken that bond, making it a stronger acid. All right. So explain why the following trend is correct, all right? Well, hypochlorous has 1 oxygen, chlorous has 2 oxygens, chloric has 3 oxygens, and perchloric has 4 oxygens, all right? So that is correct. All right, we're almost done. Let's finish this off. So which of these would produce the most acidic solution? All right, so we're looking at which one's going to have the greatest pull on that hydrogen's electrons, okay? So automatically, I'm going to kind of nix these guys, all right, because we said that chlorine is the most electronegative element, all right? And size isn't going to make a difference because the H is directly on the O each time. So the size of the chlorine and the bromine iodine, the astatine, isn't going to make any difference, okay, because the H is on the O every time. So it's just electronegative is my answer here. So I'm going to get rid of these guys, all right, because, you know, chlorine is clearly the more electronegative of these, choices here. It's a big 4. So now, is it one with 2 chlorines or one with 1 chlorine? What do you think? Well, if you said the one with 2 chlorines, you are right. Okay, so which one of these is more acidic? All right, hydroiodic acid periodic acid or perchloric acid? Which one is more acidic? Again, where is the hydrogen? Is it on the O directly or is it on the iodine or chlorine directly? Well, it's on the O. So the size won't make a difference, will it? So which one is it? It is this one, right? Why? Because the chlorine is more electronegative. But what about here? The H is still on the O's, but here I have 2 O's, here I have 3 O's. Which one's more acidic? If you said this one because it has more oxygens again, then you're right, okay? Finally, which of the circled protons is more acidic? Here's the 2 circled protons, all right? So which one's more acidic? You think about it and let me know. If you said A is, you're right. Why? Because it has 2 oxygens. Remember what we said earlier, the more oxygens, the weaker the OH bond, the more easily the H is going to come off, the more acidic it is, all right? So there's 2 oxygens kind of pulling away on those electrons, making it more acidic. So by the way, this is formic acid, so it's written as an acid, and this is actually methanol, which is an alcohol, which is a really pretty weak acid there, okay? So this name even has acid in it. This is an alcohol. So FYI in that case. And that is it. We're done. So that wraps up chapter 15. So don't wait to be great, and we'll see you next time. Bye-bye.